Hello friends, in today's video we are going to write a program for 8-bit division. So let's see first of all example that how this process is done in 8085 microprocessor. So assume right now I am taking decimal numbers. Assume you want to get the output of 8 by 3. Here 8 is the divisor, 8 is the dividend and 3 is the divisor. So simply in microprocessor what we are going to do, we will be performing 8 minus 3 and the result will be 5, and here we will be checking for carry, whether carry is 0 or carry is 1. Okay, we will be checking for carry is equal to 0 or carry is equal to 1. In the case we are getting carry is equal to 0, then again we will subtract the value, but before that we will increase the content of any register, say a register C. Earlier we had taken it as 0 0, and this time on increasing it will be 1. So let's see again. First of all we will be performing subtraction. 8 minus 3, answer will be 5. We will be checking for carry. If carry is 0, in that case we will increase the content of register C, that is up to 1. Again we will divide. We will subtract this number by 3. This time we will get 2, and again we will check whether this is greater than 0 or less than 0. So carry will be 0, that means this value is greater than 1 and greater than 0, and again we will increase the content of C. This time it will be 2. Again we will subtract the number 3 from 2. This time we will get minus 1, and obviously carry will be 1, and if carry will be 1, then we are not going to increase the value of C. So, and after that what we are going to do, we will simply add the original number again. So here we will get 2. Well, what we are doing here, when you will be performing it by 3, then your quotient will be 2, and you can write it as 2 plus 2 by 3. Here this term is quotient and this term is remainder, and this term is your divisor, as you already know. So in our answer we will be using these two numbers. One will be remainder and second will be quotient. And see, here we have achieved it. In the C we will be having quotient, and here in accumulator we will be having remainder. Okay, so let's write the program for this. So assume that at address 2050H dividend will be given, that means the number. Okay, and then at next address I'm assuming that divisor will be given, and on the next address I am going to store quotient, and on the next address, at the next address we are going to store the remainder. That means in this program consecutively 4 memory locations will be used throughout this program. And remember, when we have to access a set of memory locations, then we use instruction LXI instead of writing LDA. Okay, so that's why we will be starting this program with LXI H comma 2050H. By writing this, we are putting 2050 hexadecimal value in register H and L. Okay, and after that we are going to store the dividend in the accumulator. So we are going to write MOV A comma M. This instruction means the content of memory, and remember that memory address will be given in HL register pair. So that means content from 2050H, that means dividend. So for our example, assume this is 08 and this is 03. So 8 will be copied to the accumulator. Okay, and then in order to access the next number, I am going to write MOV B comma M. It means I want to copy the value from memory to the register B, and this time I want to copy number divisor to the register B. So that means we will have to increase HL, because the content of HL must be 2051 if you want to access that number divisor. So in order to get HL 2051, we will be writing INXH here. So let's see, first of all, you initialized HL with 2050, then you get the value dividend 8 from that address into the accumulator. Then we increased HL again, this time HL will be having 2051H, and then content of that address, that means 03, it will be copied to register B. Okay, and in my example I told you what we are going to do. We are going to subtract divisor from the dividend, so that's why I have kept the value 8 in accumulator. Well, now we will be writing SUB B. Okay, so on subtracting, this time it will be 8 minus 3 and accumulator will have 5. And then, as I said, we will be checking for carry, and in this case when we are getting carry is equal to 0, then we are again subtracting the divisor from the remainder in the accumulator. Okay, that means for carry is equal to 0, we have to again subtract the value. So we will be using instruction JNC here. So JNC, and we will be going to repeat the subtraction. Okay, remember I said earlier that we will be taking value 00, initial value 00H in a register C. So first time when we are subtracting the value, then content of C must be 00, and again on checking for carry, we have to increase that value. That means we have to perform increment operation after checking the carry is equal to 0. And when we are checking carry is equal to 0, that means we have to go back at some place. That means we will have to increase this counter value somewhere here in between. Okay, so that's why I'm going to write here INRC. INRC means we are going to increase the value, and when first time this program will be running, at that time the content of C must be 0 here. That means after increasing first time, you know, first of all this instruction will run, then this instruction will run, then here this instruction will run. So at this stage, after increment C, we want to get 00H in register C. That means that we will have to initialize the value C by FFH, because when we will be adding 1 to FFH, we will be getting 00 in register and 1 will be part of carry. Okay, so that's why we have taken FFH value in C. Now at this stage C will be having 00, and after subtracting we are going to check carry. If carry is not present there, then increment in C will occur, and this time for our this example, you know, we had taken 8 in accumulator and 3 in register B, and here 8 minus 3, that means 5 is the outcome of in accumulator, and obviously this is a positive number. That's why this instruction will run and we will go back at this location. Okay, and here as we had to increase the content of C, that's why C is increased, and this time it will be 01H. Okay, again SUBB will occur. That means this time 5 minus 3 will be run, and the content of accumulator will be 2, and obviously again CY will be 0, and if CY will be 0, that means again this instruction will run, and again we will go back, and this time it will be 02H. Alright, now the content of accumulator will be 2, and when we will be subtracting 2 minus 3, in that case it will be minus 1, and obviously here a carry is equal to 1 will occur. That's why microprocessor will not execute this instruction, and simply we will come out of the loop. And remember that this time content of accumulator is minus 1, and our quotient value will be 02 for our above said example. So in order to get the 2 again, we will have to add B again to the accumulator. Remember at this stage A will have -1, but after adding b you will get 2, and this 2 is our remainder that we have to store at memory location, and the content of c, that is 0 2, this is our quotient. Okay, so now we only have to store the result in memory location. So simply, as we had decided that 2052H will be having quotient, that means on increasing INX, on writing INXH, we will be getting the content of HL as 2052, and at this location we had to store quotient value. So our quotient value is in register C. So first of all we will move the content of C, sorry, we can write directly MOV M comma C. So the content of C is copied to the memory location, and on the next memory location we had to store the remainder at 2053H. So by writing INXH, the value of HL will be 2053H. Okay, and so now we are going to copy the content of accumulator to the memory, and after it is HLT. So this was the program for division of two 8-bit numbers using 805 microprocessor, and think it was very easy. So please like my videos and don't forget to subscribe. Thank you.